Hello, I would like to introduce the calibration procedure supporting Dynast-T. For most of the modeling effort, after the model has been initially set up, the model needs to be properly debugged and cleaned to make sure that there are no connectivity issues or coding errors. These comprise the basic network cleanup that needs to be performed after the initial setup. Once all the network-related errors have been cleaned and the model performs an assignment, the results can be compared to actual counts collected from the field. If the counts do not match, the next step is to consider adjusting or fine-tuning the OD matrices. This is what we call a two-stage OD calibration. Dynast-T is a dynamic model that takes OD information as input, so there are two things we are concerned about when it is calibrated. The first thing is we want to make sure that the total observations match, and the second is we want to ensure that the speed profile at the location of interest matches with the field data. This is one of the most difficult tasks to perform, but it is also essential as it ensures that the DTA model not only captures the total traffic volume, but also the congestion patterns. The Stage 1 calibration matches for total counts, and the Stage 2 part of the calibration matches the departure profiles to help calibrate the speed profiles. Therefore, without altering the total demand and by fine-tuning the departure of different OD pairs, we can help the model better match the field-observed speed profiles. Here's an example of the Dynast-T OD calibration procedure. This is a network based on a freeway, I-70 East, on the west side of Denver. The original model that was given did not have well-established OD information. The red dots on the graph show the initial OD of the assignment, and the comparison between the simulated count and observed count is all over the place. The Stage 1 calibration allows the simulation count to properly match the observed count as can be seen with the blue dots by ensuring that all the points are on the 45-degree line. The Stage 2 calibration is able to match the speed profile of the model with the profiles observed in the field. Here is the speed profile information for a particular location found in the bottom left graph. The red line shows the data, while the blue line shows the simulation results. While the count data matches, the speed drop due to a bottleneck is actually more severe in reality than in the simulation, as shown by this discrepancy. Through the Stage 2 process of fine-tuning the departure curve of the OD information, we are able to match the speed profiles very well. The Stage 1 and Stage 2 procedures are fully automatic, and that is part of the beauty of Dynast-T, to be able to automate the process with minimum human intervention. This is the most effective way to perform calibration on original models, where the number of OD pairs and times of interest are often in the millions or even billions.